Conservation of momentum. And the basics of conservation of momentum states that momentum before collision equals momentum after collision. For that to work, we are assuming a couple of things. We are assuming there's no rebound on collision and that both objects collide and move together. So there's no bouncing off. And at the moment, we're going to be ignoring losses due to friction, wind resistance, etc., etc. So that's the basis of our questions today. Momentum before equals momentum after. We know that momentum is mass times velocity. The greater the mass of an object, the more momentum it has. And the greater the velocity, the more momentum it has. So if we've got big mass and big velocity, we've got a lot of momentum. We know that mass is in kilograms and velocity is in meters per second, SI units. So momentum is mass times velocity, so the unit of momentum is kilograms meters per second. So a quick example. We have a mass. So this red ball, 500 kilogram mass, and it's going this way at 2 meters per second. We also have another mass, 1,000 kilograms, going in the same direction at a velocity of 0.5 meters per second. That ball there is going to collide into this ball here. So this is before collision. After collision, they've collided. There is no rebound, so these two objects stick together and move off together in a certain direction. In this case, I think they're going to go that way with a certain velocity, or they may stop. But they're both going that way, so there's a chance, a big chance that they're going to go that way. So when they've collided, they're going to have a mass and they're going to have a velocity. Now we're going to use momentum before collision equals momentum after collision. So momentum before, momentum is mass times velocity. So mass times velocity, that would be the momentum of the red ball, and mass times velocity would be the momentum of the blue ball. After they've collided, the momentum of the two objects is now going to be m3 times by v3. So momentum before collision is momentum after collision. So m1v1 plus m2v2, that's the momentum before collision, equals the momentum after collision, m3v3, m3v3. Assuming no rebound and no loss in mass, m1 and m2 collide together, so m3 is simply m1 plus m2. So the red ball and the blue ball have collided together, and m3 is going to be m1 plus m2. So in this case, it's going to be 1,000 plus 500. So m3 after collision will simply be 1,500, assuming there's no loss of mass. So there's my formula. m1v1 plus m2v2 equals m3v3. So this part here is before the collision, and this bit here is after the collision. Momentum before is momentum after. Now it's a case of putting the numbers in, because we want to find what v3 is. We need to find what v3 is. We need to find its velocity after collision. So m1v1 plus m2v2, m1 is 500, v1 is 2, plus m2 is 1,000, and V2 is 0.5. That's got to equal M3, which we know is 1500, because it's 1000 plus 500, and V3, so M3 times by V3. We don't know what V3 is, but we know everything else. We know this, we know this, and we know this. So we can work all of that out. So just put the little numbers in, put the numbers in, put the numbers in. 500 times by 2 plus 1000 times by 0.5 equals 500 plus 1000 times by V3. So on the calculator, 500 times by 2, 500 times by 2 plus 1000 times by 0.5. Close the brackets. 1500, obviously. Let's try and get a better colour. So 1500 is the momentum before. The mass M3 is also going to be 1500 because that's M1 and that's M2. Add them together, you get 1500. So now we know 1500 is 1500 times by V3. Rearrange that formula. I'm going to bring this 1500 down to here. That'll give me V3. So 1500 divided by 1500 is V3. That gives me 1. So V3 is 1 meter per second, which means that when these two collide, assuming there's no rebound and assuming conservation of momentum, this mass, which is now 1500, will move this way at 1 meters per second, assuming conservation of momentum and no rebound and no friction. So that's the basics of conservation of momentum. Momentum before is momentum after. Another example here. I've got another blue ball and another red ball. This ball is 2 kilograms and it's going this way at 3 meters per second. This blue ball or blue object is 10 kilograms and it's stationary. So it's not going anywhere. So this red ball is going to collide into this blue ball, assuming no rebound, assuming they move off together, no loss of mass. We need to find out the velocity of this. Is it going to go that way? Is it going to stay still? So we can find the mass. We know what M3 is going to be because we know that 2 and 10, M1 and M2, add them together will give you M3. So 2 plus 10 is 12. So we know the mass after collision. Here's our formula. M1V1 plus M2V2 equals M3V3. No change there. M1 is 2. V1 is 3. So M1, 2, V1 is 3 plus M2, which is 10, and V2, which is 0. So that's momentum before, and this is momentum after. We know M3, it's 12, because 10 plus 2 is 12, and we don't know V3. That's what we don't know. We don't know this. So we can just work that out. So M1, V1, 2 times 3 plus 10 times 0. Obviously 10 times 0 is 0. So 2 times 3 is 6. So 6, we can get rid of that because 10 times 0 is 0. That object's got no momentum because it's got no velocity. So 2 times 3 is 6 equals 12 times V3. So 6 equals 12 times V3. Like we did before, rearrange that formula. I'm going to bring the 6 and the 12 together. So the 12 is multiplied there I'm going to bring the 12 down underneath the 6. That will give me V3. So 6 divided by 12, half, 0.5 if you like 0.5. So when these two objects collide, that one is moving, this one's not. They'll collide together, no rebound, no loss of friction, etc. And the velocity will be 0.5 meters per second that way. Which makes a bit of sense because this is quite big and that's quite small. It has got a bit of a velocity, so the momentum afterwards will provide a velocity of 0.5 meters per second going this way. So what we've used there is m1v1 plus m2v2 equals m3v3. Put your numbers in and then calculate v3. This one, same things will apply, slightly different. Just one thing to point out. So here's my two balls again, red ball and blue ball. 5 kilograms and 0.5. This 5 kilograms is going this way. And this 15 kilograms now is coming towards it. So they're going to collide together. So afterwards they're going to collide together. This one's going that way. That one's going that way. And they're going to collide. No rebound, don't forget. We assume no rebound. So obviously, in reality, they probably would rebound and one would go up, but they'd go back. But we're assuming that there's no rebound, momentum is conserved, no loss due to friction or heat or noise. So we know M1, we know M2, which means we know M3 is going to be 5 plus 15, 5 plus the 15. So M3 is 20 kilograms when these collide together. This is 0.5 meters per second coming this way. That's 5 going that way. So we don't know what V3 is. And we're not quite sure which way it's going because they're both coming in different directions. There's our standard formula, M1V1 plus M2V2 is M3V3, M3V3. The only thing to worry about is this. Everything coming to the right we'll call positive, anything to the right we'll call negative. Which means the 0.5 is going to be positive, and because this 5 meters per second is coming the other way, we're going to put a negative number in front of it. So we can make the difference. So M1V1, 5 times by 0.5, nice and easy, plus M2, which is 15, times by V2. Because V2 is coming this way, it's 5, we're going to put a negative number in there because it's a different direction, going the opposite way to the 0.5. So we need to make that in the formula, make that difference. That's going to equal M3V3. We know M3, it's 20 kilograms times by V3. So as before, we'll work this out. We'll divide it by 20 and see what we get. If we get a positive number for V3, we know it's going this way. We might get a negative number for V3, which means it's going that way. So 5 times by 0.5, 5 times by 0.5, we can do it all in one go if you want to, 2.5, plus this. So 15 times by, don't forget the minus, times by 5, minus 75. So it's 2.5 plus minus 75. So we'll work that out. So 2.5 plus, you can do it this way. So 2.5 plus minus 75 will give us the momentum before collision, which is 72.5 minus, equals 20 times by v3, momentum after. Like I've done before, oops-a-daisy. So minus 72.5 is 20 times by v3. Bring the 20 down to leave the v3 this side. So keep the negative number in. So minus 72.5 divided by 20 will give us v3. So divide that by 20. Gives me minus 3.625, which means the velocity v3 is 3.625. The negative number just means it's going that way. When they collide, they come together, because this one's a bit heavier and it's going faster, so it's got more momentum, so it's going to collide and then they're going to move off together. So after collision, the two objects will weigh 20 kilograms and they will travel to the left at 3.625, which does make a bit of sense because this is 3 times as big and a lot faster. So they'll collide and move this way at 3.625 meters per second. So hopefully that makes momentum a bit clearer. Conservation of momentum. Momentum before is momentum after. Don't forget, we are assuming there's no rebound, and at the moment we're ignoring losses due to friction. Make sure your mass is always in kilograms and your velocity is always in meters per second. So conservation of momentum. Thank you very much.